Hello YouTube, my name is Ben and today I will be doing a short lecture on a topic for calculus. Now this is not the normal thing that we'll be doing on this channel, however we had an assignment anyway, so we're using this as an excuse to get stuff rolling. So the topic today will be on the convergence of alternating series, and I will go through the two tests that you have to use in this situation, and you'll have to do both of them in a lot of situations, and I'll follow up with some examples.
So a general form of an alternating series is the summation of n equals 1 to infinity of some equation, we'll say a sub n, multiplied by a negative 1 to the n. And that's what makes an alternating series, because every other number will be positive, negative. Now that could be the n to the power of n, could be to the power of n plus 1, power of n minus 1, or any number for that matter, or it could just stay as n and it'll alternate either way. But so when we're taking a look at these two tests, we will be taking that negative 1 to whatever power and tossing it out the window. So with that being said, let's go ahead and take a look at the two tests. So the first test we'll be looking at is the absolute convergence test. So for the absolute convergence test, we'll take the absolute value of our summation, getting rid of the negative 1 to the n power. The question we are trying to answer here is whether this summation converges or diverges. If it converges, we say the original summation with the negative 1 to the n power converges absolutely, and then we're done. However, if it diverges, we move on to the alternating series test, also called Leibniz test. For this test, our summation must meet three conditions. The first of these conditions is that all the terms in our summation are positive. The second condition is that the derivative of the equation in our summation is negative. For our third condition, we do the nth term test. For this condition to be met, the limit as n goes to infinity of what's in our summation must be 0. If all of these conditions are met, we say that the original with the negative 1 to the nth power converges conditionally, which is not to be confused with converging absolutely. Now, if any of the conditions are not met, we say that the original diverges completely. For our first example, we'll use the summation of n equals 1 to infinity of negative 1 to the nth power of 1 over n to the 3 halves. Now, I always start with the absolute convergence test because if we find that it converges absolutely, then we won't have to mess with Leibniz tests at all. To start this test, we'll take the absolute value of our series, getting rid of the negative 1 to the nth power. We know that the sum of n equals 1 to infinity of 1 over n to the 3 halves is a p-series. In this case, p equals 3 halves, which is greater than 1. So this series converges, meaning our original series converges absolutely by the absolute convergence test. For our next example, we'll use the summation of n equals 1 to infinity of negative 1 to the power of n plus 1 times 10 to the power of 1 over n. Again, we'll start with the absolute convergence test. Looking at the absolute value of our series, we have the sum of n equals 1 to infinity of 10 to the power of 1 over n. Using the nth term test, we can see that the limit as n goes to infinity of 10 to the power of 1 over n equals 1, which is not equal to 0, therefore this series diverges. Note that in using the nth term test here, we are not testing for conditional convergence of the alternating series test. Since our series diverged, we get to move on to the alternating series test. Looking at our first condition, we can see that for all the numbers we plug in for n, for 1 through infinity, will give us positive terms for this series. This condition is met, so for our second condition, the derivative of 10 to the power of 1 over n has to be negative. Now I had a brain fart on how to find this derivative, But thanks to Wolfram Alpha, we know that the derivative is negative 10 to the power of 1 over n times log of 10 over n squared, which is negative. For our last condition, we do the nth term test. Like before, we see that the limit as n goes to infinity of 10 to the power of 1 over n equals 1. Since this is not equal to 0, this condition fails to be met, and therefore our original series diverges completely by the alternating series test. This will conclude this lecture on the convergence of alternating series.
So this being my first video and my first lecture video at that, I know I may not have been as clear on some of the points as what I could have been. So if you have any questions, just go ahead and leave them in comments below, and I will do my best to answer them in a timely manner. Feedback is appreciated, and thank you for watching, and also check out our other videos that we'll be putting up.
I need Sparky juice!